All right, today we're going to pull back the curtain on something we all do, but almost never see the other side of. I'm talking about surveys. We're going to follow the journey of your answers, from the moment you click submit, all the way to a clean, powerful data set that's actually ready for analysis. You know the drill, right? You fill out the questions, you get to the end, you hit that button, and poof, it's gone. But what happens next? It's not like your answers just magically turn into a pie chart. There's this whole crucial, really meticulous process that happens behind the scenes. So the whole research journey really has three big stages. First, you've got the creation and sending out of the survey. And at the very end, you have the fancy statistical analysis, where all the big aha moments happen. But today, we're going to live in that vital and often invisible middle step, data preparation and coding. This is where the magic really happens.
And here's our game plan. We're going to start with the absolute foundation, the blueprint, which is called a codebook. Then we'll look at how your answers actually get translated into a format a computer can read. We'll tackle those tricky open-ended text questions, and then we'll dip our toes into the first steps of analysis. And finally, we'll get into how we can tell if what we found is actually a big deal. So let's jump in with that blueprint.
Okay, first up, probably the single most important document in this whole process, the codebook. The best way to think about it is like the Rosetta Stone for your survey data. It's the key that translates everything we say and click into a numerical language that software can actually understand. So, what is it really? A codebook gives a short, unique name, a variable name, to every single question. And more importantly, it assigns a specific number, or a code, to every single possible answer choice. This is what makes sure that every response gets recorded in the exact same way, which is absolutely critical for accuracy. And here's what that looks like in the real world. For a simple question like sex, the answers get coded, 1 for male, 2 for female. For a question where you enter a number, like how many bank cards do you have, the codebook just says, hey, enter the number. And for a multiple choice question like class, each option gets its own number and order. See? This is the codebook in action, just creating simple rules for everything. Okay, so with our codebook as our guide, we can get to the next step, actually getting all those answers into a structured file. This is the part where we turn individual responses into those neat and tidy rows and columns you see in a spreadsheet. And there is a golden rule here that makes everything work. It's so simple. Every person who took the survey gets their own row, and every question in the survey gets its own column. That's it. So if you surveyed 200 people and asked 5 questions, you'd end up with a spreadsheet that has 200 rows of data and 5 columns. Simple, clean, and organized. But what about those check all that apply questions? This is where it gets really clever. Instead of having one column for that question, each possible answer gets to be its own column. You can see it here. If you checked clothing, you get a 1 in the clothing column. If you didn't check music, you get a 0 in that one. It basically turns each option into its own little yes or no question. Now, this is a really big deal, and it's something that can easily trip people up. What do you do with missing data? If someone skips a question asking for their age, you should never put a 0 there. Why? Because 0 is a number. If you try to calculate the average age later, that 0 will completely throw off your result. You just leave it blank. The only time a 0 is okay is for those checklist questions we just saw, because there a 0 just means, nope, didn't select it. Okay, numbers are one thing. They're pretty straightforward. But what about those questions where people type out their actual thoughts and feelings? Let's talk about how you tame all of that text and find real patterns. You know, this process is part art and part science. A researcher has to literally read through the responses and look for common themes. So here, in this Harvey's Market survey, answers like, I like the vegetables, and meats are fresh, all get grouped together under a new category called selection/quality. And things like weekly specials and best deals become low price. This is how you start to quantify what people are saying. A quick tool that can help with this, at least at the beginning, is a word cloud. It's a really simple visual that just shows you the words that were used most often in all those typed out answers. The bigger and bolder the word, the more people used it. But, and this is a big but, word clouds have some serious limits. Yeah, they're great for a quick first look at what themes might be popping up. But the big problem? They completely ignore context. The word bad could be from this is a bad product or this is not bad, and a word cloud has no idea. They also miss ideas that are said differently, like too expensive versus price was too high. So once our data is clean, coded, and all structured, the fun really begins.
We can actually start summarizing everything to see what the data is trying to tell us. This is our first step in finding the story that's hidden in all those numbers. The very first thing we want to understand about any set of numbers is its central tendency. That sounds kind of technical, but it's a super simple idea. Where's the middle? What's the most typical or representative value in the whole group? And we've basically got three main ways to do this, the three M's. The mean is just the good old-fashioned average, great for things that are pretty evenly spread out. The median is the value that's smack dab in the middle if you line them all up, which is much better for things with crazy outliers, like income. And the mode? That's just the most popular answer, the one that shows up most often.
Now, a lot of things in the world follow a really predictable pattern called a normal distribution. You probably know it as a bell curve. And it has this really handy rule of thumb. About 68% of your data will be within one step, or standard deviation from the average. About 95% will be within 2 steps. And pretty much everything, 99.7%, will be within 3. This predictability is what a ton of statistics is built on.
And now for the final and maybe the biggest question of all. We almost never survey an entire population, right? We just talk to a smaller sample. So, how can we be confident that what we found in our little group is actually true for the whole story? Let's talk about gauging true significance. The answer lies in this powerful, almost magical idea called the central limit theorem. What it says is that even if the population you're studying is all over the place, if you take enough random samples from it and plot their averages, that new picture of the averages will form a perfect bell curve. And that is what allows us to use one single sample to make really confident guesses about everybody. This leads us to the famous and, let's be honest, often misunderstood p-value. The simplest way I can put it is this. The p-value is a measure of how surprising your result is. It's the probability that you would see the result you got just by pure random chance, assuming that your idea is wrong and there's actually no real effect out there. So here's how to think about it. A low p-value, usually less than 0.05, means your result was really surprising. It was unlikely to be just a fluke, so you can be more confident it's a real effect. A high p-value means your result wasn't very surprising at all, and it could have easily just been random luck. But, and I cannot stress this enough, it's so important to remember what a p-value is not. It does not tell you if your finding is big or important, just that it's probably not random. And most critically, it only accounts for random error from sampling. It tells you nothing about other mistakes, like if you accidentally surveyed the wrong people or wrote really confusing questions. And we'll end with this thought. This whole journey, from clicks to clarity, gives us powerful, solid numbers. But as this quote suggests, those numbers ultimately have to be woven into a compelling story. Because in the end, the goal of all this work isn't just to make data, it's to create real understanding.